Alright, I think we're ready. We're going to do our first print. Actually, I've already printed on the printer a little bit just to make sure everything's working, but our first official print. And we're going to look at the first cycle of calibrations that we're going to do to get our prints working pretty well. Now, the first print I actually did off of this thing, it worked fine. There weren't any real problems, and that's probably true for most of these printers, is that you can set them up, and as long as you get the bed and nozzle clearance, so the distance between the nozzle and the bed more or less right, then you're going to be able to print pretty well out of the box with these things. But we are going to go through a first set of calibrations. I think we're going to do 1, 2, 3, 4, maybe 4 different calibrations that are that don't require us to do any like firmware changes or anything. You can do them all without any of that stuff. Technically, sort of, we are modifying a parameter in some of the firmware, but you don't have to upload entirely new firmware. The firmware is what's running on the board inside here. Remember, we looked at it last time, and so there's this little computer board in there, and it does have its own firmware that's kind of like its operating system, and there are a variety of those that you can install. So we're not actually changing that today. We're just modifying some parameters inside of it. And you'll notice I've got this cable right here. I have plugged into USB. There are other ways, and some, depending on what printer you have, you may even be able to do some of these changes just using the control panel over here. I'm going to use a USB cable, so it's going to be connected into my computer, and again, this is an Ender 3, and that's the simplest way to do this for me, but I haven't even checked to see if in the menu there are settings. Yeah, there are. So we could change this using just this menu, at least for several of these things. But I'm going to show you how to do it, assuming you have a cable, because you can always use the cable. You can't always use the control panel. That depends on what firmware you have installed and everything. So, plus it'll be easier to see what's actually happening on the screen, and plus we'll get to look a little tiny bit into G-code. So what happens when you run one of these prints? There's several stages. So first you get a object you want to print. So either you've created something in SolidWorks, or a CAD modeling program, or maybe you've even scanned in some data. So you get this object. Then you take that data, the digital version of that object, and run it through what's called a slicer. And there are a whole selection of slicers that you can use. We'll look at one today. And that slicer, what it does is it takes the digital geometry and slices it layer by layer and converts all of the movements that need to happen into what's called G-code. You put G-code somehow on the printer. So sometimes you put it on one of the, well, actually on one of the little SD cards. A lot of these printers use these little SD cards. I don't really like the micro SD cards just because they're harder to handle. But a lot of them either use a micro SD or a regular SD card, and then you run the print. The print at that point is just a set of instructions called G-code that the board inside your printer knows how to respond to. There are other ways. You don't have to use the G-code. We could print, in fact, our first print, our first print that we'll do today, we're just going to use the cable here, and so just talk to the printer directly from the computer. And that's not as common, but it can be done. Later on in the quarter, let's see if I can see roughly where. Well, actually quite a bit later, a month from now, we're going to install, somewhere around a month from now. I don't know exactly when we'll do this. Good morning. I see a chat. Good morning. Octoprint is a similar approach to the USB cable, except that it's wireless, and I actually like it quite a bit. it kind of makes it simpler. You don't have to deal with the SD cards, and you don't have to deal with the USB cables, and you can just send the files directly over your network on your wherever you're at, your local network. I do like that, but about a month from now we'll look at that. In order to do Octoprint, you do need a separate microcontroller. We're going to use a Raspberry Pi to do that, so we'll get into that later. Let's look at our first print and some of the calibrations. Actually, let's look at some of the calibrations first and then our first print. In order to do these calibrations, I am going to be using this piece of software. This is Pronterface. You can, I don't know, it's really tiny up there. Pronterface. Let's see if I can find it. You actually look for print run, I believe, is where you, yeah, here we go. So pronterface.com, and it should be a free download from GitHub or where there's a Windows binary you could use, but you could get it from right here. Now notice also, let's go back, the most recent version of this was from 2014, so it hasn't been really changed since then, but it works fine. And so you could download a zip file of this, and inside here, let's see if I can see it, inside here is going to be your Pronterface program. So the bigger thing is print run. The particular piece we want is called Pronterface. Don't know why that's what it's called, but that's what it's called. Let's see if I can get it back on the screen. There we go. So what this does is you can use this to print direct. If you have a sliced file already, you have a set of G-code, you could load it here. In fact, we'll do that in a minute, and print directly with this. What I'm going to mainly use it for is connecting to the printer and sending individual G-code commands that I type in. So to connect it to the printer, over here in the top left, you've got COM ports. I've got 9, 10, and 1. If you're not sure which one to use, you could just try them all. It'll only connect to one of them. But probably 9 is the one that I want. But you could go into Device Manager. Oh, a question. Do you have to do this calibration again if you update the firmware later? Yes, if you change the firmware, unless you type all of these commands, or not commands, but these parameters into the new firmware, it won't store your old parameters. So you'll have to recalibrate every time you completely overwrite your old firmware. So if you get all this stuff right and then don't record the values that you have determined, then you run through these calibrations again for the new firmware every time you completely overwrite it. There are, I think much later in the quarter, we'll get into some of the firmware that you can change on the fly, where you can change just individual parameters without having to upload an entire new firmware pretty easily. But that'll be much later in the quarter, and it's not the base firmware that comes on all of these Enders and TiVos and those sort of printers. Like I was saying here on the COM port, you usually have a couple. It's usually not COM1. COM1 is probably your mouse or something like that. So it's usually one of the higher ones. I think mine is 9. If it's not, it won't connect. This is the baud rate. 115,200 is usually the default that you're going to use, but there are others. I would not change that at first. I would keep it there. Most of all the printers I've ever seen talk at this rate. And then you hit connect. And so it didn't like that one. So let's try 10. Maybe it's 10. All right, there you go. So it was 10. So that's all that happens if you pick the wrong one, is it says it cannot connect. Now, I guarantee at some point, if you use one of these type software, Pronterface type software interfaces, you're going to get it to not connect on any of these COM ports, and it'll say access denied in this little error message over here. Instead of saying the system cannot find the file, that kind of thing, it will say access denied. 9 times out of 10 or more, maybe 99 out of 100 times. What that means is that you have left your slicer software open. So whether you're using Cura or Prusa slicer or whichever one of your slicers you're using, you've probably left it open, and it has control of your printer. So if you're getting a error message over here, access denied, check your Windows, and there's a good chance that Cura is running. And as soon as you plugged in the USB cable over here, then Cura said, oh, well, I'll just take control of the printer. And you can do some of these things through Cura. I don't like its interface for writing G-code quite as much, but you could. It does have like a little terminal section that you can kind of work in. But just shut down Cura or whatever your slicer is. Try to connect again, and it should work fine. All right, and now we have the printer is now on line message. All of these controls over here are for moving it and homing it and turning on heaters and the bed heater. Looks like I've got some, I can extrude, things like that. And we could do that. We should be able to, move in the X direction. Well, you can't see it moving, but you can hear it probably. So you could click these buttons, 0.1 millimeters up to 100 millimeters at a time. Some of your printers won't let you move anywhere depending on the firmware they're running. They won't let you move until you've homed that axis, because it doesn't know where it's at and it's afraid it might collide into something. And so there's sometimes that you click on these and it won't move. A lot of times that is because you haven't homed that axis yet. This particular one didn't care, so I could move it. I could probably send it all the way across and it would eventually just hit something. All right, so the first bit of tuning that we're going to do is called, and then this one is low level important. It will be fine to not tune this one, but it does help a little bit of tuning the print a little bit, and it's not hard to do, and it's a nice fun little thing to do. It's called PID tuning, and that's a proportional, integral, and derivative control scheme. So proportional, like if I raise this number, then I get a corresponding raise in the temperature or whatever. And then integral is you've integrated the area under the curve, and then derivative is you're looking at the rate of change of things. So it's going to take these three parameters and take these three variables and find the best parameter, the coefficient, to match up with each one of those. And the goal is that I want to set the nozzle temperature to 200 degrees, for instance, and I want it to get there as quickly as possible without a lot of over and undershoot. So I want it to kind of get to 200 and stay at exactly 200. It won't be able to do exactly that, but it will ramp up, maybe overshoot a little, undershoot. I want to minimize those over and undershoots, and I want to control that temperature. You can do this for the hot end itself, where the filament comes out, and you can also do this for the bed. So the bed is not quite as important, but on larger prints, so let's look at the thing. On larger prints, if you don't have PID tuning on the bed, what can happen is it defaults to what's called bang bang tuning, and again, this is dependent on what your firmware is set up initially. It might your hot end and bed on most printers do have PID tuning values turned on to begin with, but those were set either just as the default numbers for a typical printer, or if they were actually calibrated, then it was calibrated somewhere far away from where you are, and your particular setup is in a different environment, and so those parameters won't be exactly what they need to be for where your printer is sitting, and so they'll work fine, but you can make them work slightly better, and that's what the goal of this is. Back to the bed, if you use what's called bang bang control system on the bed temperature, what that means is that basically there's a set point, maybe it's 50 degrees for the bed, and it's on until it gets to 50 or some number right above 50 or whatever, whatever the threshold is, and then bang, it's off, and it flip-flops between on and off to kind of control the temperature of the bed, which is similar to PID tuning, but it's not as refined. So it's just on when it gets above it a certain threshold, or it turns off until it gets below a certain threshold, and then it turns on and off and on again. And what that'll do to your prints, if you have a large print on a bed that's controlled that way, you'll see stripes in the wall of the print. I'm pointing to something you can't see. In the wall of the print, you'll be able to see like little stripes. And what's happening is, as this bed is heated, then it kind of deflects one direction. So let's say it bows up. And then when the heater is off, it kind of bows back down with the temperature change, deforming the bed. And so you'll get these stripes periodically in the wall of your printer, in the printed thing. So how to do this? Let's go back to our picture here. So down here at the very bottom is where I'm going to write G-code in. And first of all, for PID tuning, the goal is that I want this nice smooth control system that's going to be able to hit a set point temperature for the nozzle. We'll only do the nozzle. We won't do the bed. It's the same process, but I want it to be able to hit a certain temperature for the nozzle, and I want it to stay there as much as possible under the printing conditions. So you need to have your printer where it's going to be. You know, if you want to put it in a separate room or in a certain location, it needs to be in that location. You need to have filament loaded into the printer. So I've got this orange filament over here. If you haven't loaded filament yet, then all you need to do for that is most of your printers have a load filament option on the control panel. If it doesn't, then it has a Preheat Pla. Most of you are printing with PLA. So it has a Preheat Pla where basically it's just going to heat the nozzle up. You pinch the little drive wheel out of the way, feed the filament through, and then it'll come all the way through to here, and then you'll be able to manually push enough filament through until you get a little bit of a purge coming out of the nozzle. And if you don't have filament inside of here, then it's not going to respond quite the same way as it would if it was empty. So you want it to have filament on. We also want this side fan on if you're printing PLA. This side fan, this fan should be on all the time. The one on the front, this fan is cooling the hot end. So we'll look at the hot end in more detail later, but basically there's two zones to it. One that needs to stay cool, and then the very end of it that needs to stay hot. This fan makes sure the cool side needs to stay cool. This fan on the side is actually pointing down, and it's going to cool the print that you just printed. And PLA needs that. Other materials don't need that as well or as much. But PLA does need this side fan on. So if I'm printing PLA and I want to do PID tuning, I want to have PLA filament in there, and I want to turn this fan on. So let's turn the fan on first. We'll do that with G-code. M, so I said it's G-code, and the very first one we do starts with an M. Most of them that start with G have to do with moving the print head around. But the ones that control the machine, like if things are on or whatever, is M. So we've got a M106 is for the fan, this fan on the side. And then S is the set point that we want to go to. And for fans, it goes from 0 as off to 255 is full speed. And then anywhere in between is, it's like half speed or whatever you set it to. So I send it that, it says sending M1, whatever, and you can kind of see over here that this little line bumped up to 255, and it's called fan. It just means the fan is on 100%. If I did, 125, you can see the fan kind of drops down to half speed or so. I want full speed. All right, so the fan's back on full speed. Oh, except I put 225. Let's do 255. All right, fan's full speed. You could go ahead and heat the nozzle up, but the PID tuning itself is going to do that. So we'll just go into the PID tuning. So that's M. Well, first let's do 503. M503 is going to report all of the settings that are stored in my printer. So you can see when I send it to M503, I get all of this stuff. And in here, you can see there should be two sets of PID. I got to find them. Here they are. So the 301 and the 304. The 301 is the parameters for the hotend, and you can see a P, and there's an I, and there's D right there. Those are the coefficients for those three parameters for the hotend. And then the 304 version, same parameters for the bed. So the fact that I have M304 listed here means that my bed is already set to have PID tuning. I just might want to check if these parameters are the right numbers for the new location for this printer. All right, so that was M503 reports all this stuff. To do the PID tuning, you do 303. That's the tuning of the, well, that's tuning PID tuning. To tell it what to tune, you do E0 for the hotend, E-1 for the bed, and if you have a printer that has two hotends, two heaters on the, in two different nozzles, E1 would be the other one. E0 is the default nozzle for most all your printers that have just one nozzle. Then we need to say what temperature, so it's another S for kind of this setting. We're going to do 200. That's pretty much the temperature most of your PLA is going to print at, so we might as well tune for that temperature. Maybe you're going to print a little hotter, so you tune it to 205. Or maybe you're printing a different material. Maybe you're printing ABS, so you want to tune to 240. But we'll do 200 for kind of a average value. We're going to put U1 on here. This U1 may or may not work in your printer, and what it'll do is it stores these settings in RAM. It stores them in RAM, and then we can permanently store them in ROM once we get them. So you hit enter, send, whatever you want to do. I hit enter, and it did this PID auto tune start. There are some other parameters. We're taking most of the default ones, and you can see over here the little blue line, EX0. That is extruder 0, which is the only extruder you have in most cases, and it's gradually ramping up, and it's going to go up to 200, and then it's going to cycle on and off around 200 a couple of times. I don't know what the default is. You can actually make it do any number of cycles you want it to do with the C for cycle parameter in this same line of M303. I think it's probably going to do 3 by default, but I don't actually know that. I didn't pay attention. Then it will report back to me on the screen here what it thinks the values for P, I, and D are going to be. While it's doing that, when it does something interesting, we'll come back to that. But right now, it's not very interesting. It's just kind of heating up right now. All right, so remember down here, way down there, my Z stepper motor was not lined up right. What I ended up doing is I just put 2 pieces of shim cardboard to set it off, and it lined up perfectly. So you shouldn't have to do this, but what was happening to mine is the Z screw, when I lowered the bed manually, like turning this by hand, it was just too difficult to turn, and so it was binding. And once I set it off, and lined this screw up better, parallel to the vertical axis here, it worked a lot better. So all I did was shim it out with a couple of pieces of cardboard. A comment about, is there some form of command directory? Oh, there is. What do I usually do? Oh, let's look at the screen here. You can kind of see some of the cycling where it's overshooting and undershooting. This is it cycling to figure out those P, I, and D tuning commands. Yes, I usually search for, Marlin G-code. Marlin is the name of your firmware on most of this level printer. And this marlinfirmware.org has every, like over here on every G and M command that you can think of, and it has examples for most of them, and all the different parameters that you can apply. So marlinfw.org is what I usually use. Oh, I didn't type that right. Marlin FW. There we go. That one is pretty. I don't know if there are any things that aren't in here. You might be running a different firmware, but there's a good chance that you are actually running Marlin if you haven't changed anything. So marlinfw.org is where I usually go to find the reference for all these G-code commands. All right, so it gave me some values here. Oh, well, it's still working. It hasn't decided yet. It's iterated a couple of times, and it has spit out a couple of values, but it's not quite done yet. And you can kind of see it's still cycling. Looks like it's in an off cycle right now. Oh, all right, it gave us our values. All right, so PID auto-tune finished, and then you might, if you didn't do that U1 command right here, then these are not stored locally on your printer, and you have to manually type them in. But with the U1, all we have to do is M500, and it will save all of the current parameters, whatever they are, not just PID, but all the current parameters, it'll save them. And let's look at our old ones. Our old ones were 24.85, our new one's 24.76. So we can do M500. It doesn't tell you that it did anything. That's why you do the M503 to check that it actually put these into your machine. And there's the new set of PID values. You could do the same thing for the bed, except our command that was right here. First of all, you wouldn't want to heat the bed to 200. You would only heat it to maybe 50 or 60. And then instead of E0, you would use E-1. And now you've tuned the hot end for your printer's current environment. We can turn that fan off. So to do that, that's M106. 106. Not typing in the command here. M106 S0. Turn the fan off. All right. To do the first layer, so the very first thing you want to do, get these off of here. There we go. First, let's look at the printer. You need to get this little switch set roughly correctly. So what I did is I remember I tightened down all of these screws pretty tight, so that there's not a lot of room to lower the bed anymore, but I can only raise the bed. And then if you go in to your control panel, prepare auto home, then it should go through its homing routine using all the limit switches. So it's all the little triggers everywhere, and this is where it thinks it should start, 000 for the printer's origin. Now what you want to do, now you shouldn't be able to move it. Once you've homed it, it locks all the steppers in place. If you want to manually move the thing around, go to your menu here. Oh, well, let's see. Prepare, disable steppers. Now you can move these around to different spots. So move it to the middle, and then take a little sheet of paper, and like I can barely put this paper between. This is a doubled over sheet of paper, so it's 2 sheets, I guess. If you can just kind of barely pass the paper under the between the nozzle and the bed, that's about the right distance. It might be a little tight, but kind of do that in the middle. You can use that to set the height of this limit switch over here, which you can't see anymore. It's kind of covered up with the stepper motor and this housing. Let's see if we can get down there to it. loosen these two screws to raise and lower this limit switch to where you're more or less, it would be better to have a bigger gap between the nozzle and the paper than a smaller gap at this point, because we've got our springs pretty much tightened all the way down. So do that. Then what you do is you home again. So I didn't change mine. Mine is in the same spot, so I don't have to home again. But if you move this, then do another auto home, or at least a home on the Z-axis. And then go over to, you know, somewhere in this corner. Let's move out further. Somewhere in this corner, get your paper, and you want to be able to feel that there's some amount of drag, not a lot. You're not trying to get these things super close. If you get the nozzle too close to the bed, then no filament can come out. And so you want some gap. You want to be able to feel a gap, and you turn just this knob until you feel a tiny bit of drag between there. So either, you know, a doubled over sheet of paper, maybe some cardstock, feel a little bit of drag. And then do that to each one of the corners, adjusting that knob each time. So that's a general process called leveling the bed. It has nothing to do really with like putting a level on the bed. What you're really doing is something closer to tramming. This one felt kind of tight. No, I guess not. That feels okay. That one's actually kind of loose. There we go. There we go. All right. And so that'll get you close enough. So that one will get the bed more or less in a position where you can print on it. It won't be too far away and it won't be too close. There is a really good series of like calibrations that you can use. This is on, let's actually post this link. I posted it in maybe the notes for the video, but there it is in the chat. Here's another YouTube guy, and the one I like about this is that he has a calibration web page where he kind of and there's PID Auto Tune is his first. Actually, his first thing is frame check, so making sure that the frame is, you know, put together right, and which you should do. I guess I kind of skipped over that. And then he did do an auto tune first, and then first layer here. He has a G-code generator, and there's a lot of explanation. You can read all this kind of stuff. Now, some of this is auto leveling, which we're not going to do yet because most of your printers that you just, you know, the first printer you get probably didn't have any auto leveling built into it. And so we're going to skip over all the auto leveling and the manual mesh bed leveling. We'll do manual mesh bed leveling later. You don't need any special equipment for that, just time. But here he's got a first layer G-code generator. And what this is going to do is it's going to print 5 little squares scattered around your print bed. And you can look at each individual square to kind of get an idea of how well the nozzle is positioned at that point. What you do to get this to work is you don't need any additional start G-code unless you have done something to your printer other than just build it. You don't need to add M80 to turn the power supply on. You don't need to remove T0, so you don't need any of those. That's if MMU is multi-material upgrade. I assume that we're all basically more or less base level Ender 3 users or something similar. I think when you first load this page up, these numbers might not be set for an Ender 3. I don't remember. Assuming you let your web page store cookies, then let's say we got a little slowdown in our internet. Hopefully it comes back soon enough. All right, I think it's okay. So for Ender 3, 225 by 225, those are millimeters in the X and Y direction. Those should be good numbers. If you have a different size or different printer, then these are just the rough size of the bed in millimeters. Extra margin from the edge if you don't want to print too close to the edge. So for instance, I've got these binder clips on here, so I can't print right up against the edge. You might want to indent your location where it's going to print. Now it's already going to indent some, but you might want to indent more. I did not indent more. I left it at 0 for the extra indent. All right, looks like the stream is back to being more steady. Hot end temperature 200. Assuming you're printing PLA, 200 is probably the good temperature to use. You also, we just PID tuned for 200. Bed temperature 50 is pretty average for PLA. ABL is auto bed leveling. We don't have one, but there are other things that we could do. We'll look at that later, but not today. These retraction distances, don't worry about those right now. There actually is we're not going to do it today, but there actually is a retraction tuning that we can do to help with that. If these are off, then for an Ender 3, they should look something like this. For a different printer, then these numbers might be different. The only thing that'll happen is if you get these numbers wrong, there might be extra strings, you know, between these little pads that it's going to print. So then you download the G-code. And so this, you don't send it to Cura or anything like that. You don't have to slice it. This particular web page is going to generate the G-code directly. And so I've got this first layer G-code. I can actually print that from here. See, there's a load file. I can load the first layer G-code. It'll give me a little preview. Now, don't worry that it shows being offset. I didn't go in and set the size of this bed to be Ender 3. It's just whatever popped up from the last time I used it. And then we can print. Now, this one is only going to print assuming you have your USB cable connected. So if you don't have a cable, you need to put that G-code on an SD card and print from the print menu over here in the control box. So let's print. Now it's gonna go in. You can kind of see it turned on the bed temperature, trying to heat the bed up. It'll soon turn on the nozzle to try and heat the nozzle up. I probably should have already preheated that. So a couple of things here. Do make sure that you have filament in, because this might be, you know, if you really are the first calibration, maybe you haven't loaded filament. And so that would be a problem if you haven't. And so what this will help us do is it's going to print those 5 squares in the bed, and I'll be able to see how well the bed responds to each of the 5 corners. Ideally, you would do this a couple of times. You would print it once and then raise or lower that corner of the bed if this square looks like it's not sticking very well, or if it's too smushed down. Then you would change this knob to adjust just this corner. There's a really good chance that your bed is not flat. It's going to have either the middle is going to be higher than everything else, or the middle is going to be lower than everything else. In my case, I believe the middle ends up being higher than everything else, and so that it's not a problem too much, except that if it's too extreme, like if the middle is way higher than the sides, or there's a dip somewhere, then it's going to have trouble getting that first layer to print down. If you're printing large objects that have to span multiple regions of the bed. Now, if you're just printing some little thing in the middle, then, you know, it's not that big a deal. You can kind of see our temperature increasing here for the nozzle. You should also be able to see the same things, you know, appearing on the screen as a readout on the current temperature for the bed and the nozzle. Let's see, while it's heating up, oh, I wanted to mention these. No kits that I ever see come with tweezers, but these are really handy because almost always you're going to have some little drip of filament from the last print or whatever. And these are good for reaching in there and grabbing. Now, maybe not these with the angle on them, but reaching in there and grabbing any filament that's kind of hanging off of your nozzle. You could do that with your hands, but it's 200 degrees Celsius, so that's generally not a great idea. So you reach in here, grab that stuff off of there if there's any. But no kit really ships with these, so you can print some. There are models for printing tweezers if you really don't want to find any of your own. But I would recommend maybe one thing that you don't get in your kit that is pretty handy, something like this, just for grabbing those stray pieces off of the nozzle. All right, so it's starting our print. This is a homing routine. Almost every print every print you do is going to start with a homing routine. All right, so it's printing over here. Now, I'm noticing that no filament is coming out yet. So one thing you can do is, there's a little bit. A lot of prints will start with a purge so that they'll have filament coming out at the beginning. This one kind of just gives you outlines at first of the 5 different locations. And I can already tell that the middle is really close, but the corners are actually kind of far away. I'm talking about the distance between the nozzle and the bed. I'll let this print, and you can kind of see these little strings. That's the retraction not being set quite right. And so it's not retracting enough filament when it's making these moves, and those are the kind of strings that you'll get if you don't have your retraction set very well. It's not a big deal. You can easily remove them later, but we will do retraction tuning, probably not today, but we will do, well, I know not today, because we have some other tuning to do first, and we'll run out of time first. A lot of these calibrations are iterative, so, and they're cyclic too. So once we get the bed level, then we can go move to another. We should never actually have to re-level the bed unless we do something to, knock it out of whack. They send you these little scraper things to scrape prints off of the bed, and it is very easy to knock your bed out of level if you get too rough trying to scrape parts off of the print bed. Now this one, you can take the whole surface off. You've got these binder clips. We can take the whole thing off of there and not worry that we're going to disrupt our bed level with this. I will say, if you do take the bed cover off, the print surface off, make some kind of mark on it so you know which way it goes back. Because if I take this off and then put it back rotated, then I don't know that this surface is not the thing that's uneven. I might have a thick area of this surface and a thin area. So if I put it back in a different rotation, now my bed is unlevel because the thing itself that I put on there is not uniformly thick. And it doesn't take a lot. We're talking fractions of a millimeter to get unlevel. So getting them perfectly level within fractions of a millimeter is kind of tough. It looks, you can kind of see, it certainly did print the rectangle, or I keep calling it a rectangle, it's a square. The square here, we'll look at all of them in a second and see how they're different and what we would do to change them if we need to. Other thing I like about this is that it's not terribly long. It's only been 3 minutes or so to get the whole thing printed. There are others of these for sure. Yeah, the middle one, these will be good because they'll give us a variety of reading these different prints here, because all 3 of those are different that it's printed. I don't know if you'll be able to see very well on the camera, but hopefully you will. We just have these last 2 to do. Let's see, I think we've got 30 minutes left, so we've got plenty of time to do the other two calibrations. I don't know if we'll get too much into the slicer. We'll do one thing in the slicer as the last thing today. The slicer that I'm going to use for most of our stuff is going to be Cura. There are a variety of slicers, and each have their own good points and kind of bad points. Cura is one of the, first of all, it's free, and it is one of the ones that gets updated pretty regularly. Like, you can expect an update every few months on it, and the updates aren't always just bug fixes. They're a lot of times new features. Like, Cura usually has a set of experimental features that it throws out there for people to work on, try out, and then after they've been proven, they become permanent features, and they'll put a new set of experimental features. So most of what I'm going to do is in Cura. I'll show off some of the other slicers just so you can see them also. Looks like our print is done. Let's take our bed off of here. Remember, the bed is heated. We heated it to 50 degrees. So it will be kind of hot. All right, let's look at this. See if we can get a variety here and see. All right, so you see how, so the middle one, all the lines are touching. If you could feel it, you would feel it's a little bit rough, and you can probably see how it's a little different texture at the edges versus the center. This is actually too close to the bed. Too far away kind of looks like this one. Let's see if I can make it look the right way on your camera. Yeah, you can see how there's gaps between the individual lines. So that one's actually a little too far away. This one is about right. I don't know if on your camera you can tell the difference between this one and the middle one, but in person, the middle one's just a little bit too close, and it's a little bit too translucent. So I can see through this filament a little better than this one, and I don't like that. If I can see, we had a little bit of a disconnect there, so I'm not sure where it disconnected at. I'm watching the replay to see where we were at. I think we're good now. So these back two, let's put it back on the bed so I can show where they're at. So the back two show that the nozzle's a tiny bit too far away from the bed. This one's a little bit too close. This one is about right, and this one's a little bit too far away. So none of them are bad though. So like if I go to peel them up, this one actually, so this is the scraper that came with the Ender 3 kit. I actually like this one a little better. I don't know what printer this came with, or maybe it's another one I had, but this one actually has a much sharper edge than this one's pretty dull. So this one kind of knocks the prints off, and this one will scrape them off. So I'm going to use the scraping one. And again, so see, this is where if you do all of this scraping on the bed and it's really stuck down, you could knock your bed out of level. So I might actually take it back off of here. It's going to be hard to do where you can see it. Try and get straight down here. So there, you can kind of see how none of the lines are connected together. So it didn't actually connect everything. Don't worry too much about that, because there are some other calibrations we may need to do later. Right now we're just trying to get our prints to stick down, which they are doing. They are sticking pretty well. That one looks pretty good. This one actually looks like it might be hard to get off of there. Yeah, that's going to be a problem. So I would rather have a little bit of room underneath there. There we go. We got under it. And without the sharpened edge on some of these, if they get stuck like that, it's kind of tough to get them off of there. So this one is too close. The problem with it is that it's a function of all four of them, right? these two were already kind of low. As far as the bed was a little bit low, the nozzle was too high. So I can't really lower them much more. I could probably lower the front a little bit, and that would bring this middle down a little more. But it's also showing that my bed is not necessarily flat. So I think what I'm going to do, once I get this scraped off of here, I'll come back and scrape it off later. I'm not going to spend too much time scraping on it right now. Those were better. And we might can get this off. See how much you have to, if you get too close, you have to do a little too much scraping. And that would definitely unlevel the bed if you were doing that much scraping on top of the bed. There we go. All right, let's put it back on here. Now, when I did all of that, I was handling this bed, touching it all over, you know, turning it around. There's a good chance that I transferred all sorts of oils from my hand onto this surface, and that is going to make things difficult for the print to stick on there. Lost one of my little things. I'll find it later. So generally what I do is after every print, I spray it down with isopropyl alcohol and wipe it off with a paper towel or whatever. Or I have these also. If you don't, I have these little guys, just like the little isopropyl alcohol pads, and wipe it down to try and keep the greases off of it. So if you've done all the leveling and everything, and prints just aren't sticking, it might be that the bed surface you're printing on has gotten oily or greasy or even just dirty. So wipe it off with IPA, isopropyl alcohol, either one of these. I have a spray bottle. I just don't see it right now, so I'm using that one to kind of keep that clean. All right, so it looked like these two were probably a little too close, so I'm going to bring both of them down a little bit. This one wasn't too close. This one was actually about right. It was a little too far away, but I need to bring them down to bring this middle down a little bit. All right. And so you could reprint that again, adjust things. You can even adjust while it's printing. If you have a good enough view of what's going on, you can change these as it's printing that corner, for instance. All right, let's see the next one. So the next thing here is, the next thing is a baseline print. What this is a little calibration cube, and it is good to do. I'm not going to do that one because it does take a longer, like 40-ish minutes to print. All it's going to do is kind of give you a baseline of where your printer starts at, so you can actually see if the things you're changing are making good or bad changes in your print. You can kind of see he is going from, not a bad print, but there are some ghosting, these rounded corners, and then he got a much better print later. I'm not going to do that, but basically you could go in, it'll generate a little code with X, Y, and Z written on it. E-steps calibration. So if you have been on a forum asking any question about I can't get my print to print, the first two answers you're going to almost always get are, did you level the bed and did you calibrate E-steps? Those seem to be like the automatic answer for most anything. And it's kind of true. Obviously, if you didn't level the bed, then maybe your print just isn't sticking at all. But assuming you get your print to stick down, then the E-steps, what these are is, remember your motors like this one. Actually, in this case, we're talking about this one back here on the extruder. That's the E in E-steps. These are stepper motors. And how they work is they're not like a regular DC motor. They are DC powered, but they take individual little steps. And these steps can be super tiny, like you know, point, oh, what is it? There are a couple of degrees. I don't remember. But we'll look at stepper motors actually in detail later on. But there's like 200 steps per revolution, I think, is generally what they are set to for these stepper motors on your printer. And so the E steps is the extruder number of steps. And so you can calibrate the extruder to spit out the right amount of filament. And that's what this E steps is about. Now, the way that it's described here is I don't really like this one quite as much. Now, first of all, he's doing this on a Prusa printer. And so I'm going to change up his process here, but we still are going to do E steps. So first we need to know what our current E steps are. So let's go to Pronterface. Let's do that M503 so we can see what our current E steps even are. And you can see right here in the Echo line M92XYZE, that E, these are all the steps for the X motor or X stepper, the Y stepper, the Z stepper. Those, since they're belt driven and lead screw driven, you really shouldn't have to adjust those. X, Y, and the Z, the only reason they should be off are if the Z screw is binding and it's just not able to turn, or your belts on X and Y are loose and they're skipping, you know, something like that. So those you really shouldn't have to adjust. But E, you could need to change. Probably, if you did this on your printer and it's an Ender 3 to start with, this E value is 93. That's usually the default value. Mine is now set at 98.14. Other printers are going to have very different numbers because there are different types of feeders to feed the filament in. And some of these numbers might be 400, for instance. So you just want to know what your number currently is. So whatever number is by E in this line in your when you do M503, that's your current E steps. So how we're going to modify, or well, we may not even need to modify ours, but how we're going to check ours is I'm going to go. Let's see. I need to see back here really. Just kind of get around. There we go. I'm going to take this off. Actually, first let's, you know what? I need to turn the, hot end on. So I'm going to do, all right, so I'm going to do prepare, preheat PLA. I only need to preheat the end. I don't need to preheat the bed. So I'm going to preheat this. A lot of printers, their firmware won't even let you control this motor if the hot end is not past like 175 or 180 or so Celsius. Because it's assuming that there's filament in here, and if the hot end isn't on, you're not going to be able to, you know, force filament through it because it's not melted. So I'm going to go ahead and heat this up, and I'm going to actually pull all of this filament out so that we can look at something. It's not quite hot enough to pull out just yet, because it's, you know, it's melted down in here previously, then it cooled, and now I need to remelt it to be able to pull it out. So it's getting close. We may not get to do our very last calibration, at least not in full. I think we'll get close to it though. All right, I can probably pull it out now. So just pull all of this out, and you know it's going to have this melted end on the end of it. I'm going to cut all of that off. One good thing to know is that sometimes it's hard to feed filament, get it all lined up here. One thing that can help is when you cut this, if you cut it at a really steep angle, so that it has a really sharp point. Whoops. Sharp point on it. Not going to focus on that close. Then it makes it easier to feed in there. But right now, I don't even want this tube on. So I'm going to take that off. All right, and then it's coming out here. I want to take those little nippers that came with it and cut it off flush. So now it's flush with this surface, and it's just going to be able to spit out over here. So what I want to do is I'm going to go back to our prompter face. It's still plugged in USB, and I want to tell the printer to extrude a certain number of millimeters of filament. Now you can do this on the control panel over here with move axis. One of the move axis options is extruder, and you can just do it that way. But I want to show you how to do it in G-code, because later on we're going to look at reading G-code and writing G-code directly, and so we might as well look at what some of these commands do. So first of all, I think I want to do a G91. What that does is it's going to put the printer in relative mode versus absolute mode, so that it's going to spit out a relative amount of filament versus an absolute amount. So I want 100 additional millimeters from wherever it currently thinks it is kind of what I'm saying. So here's our first G command, G1. Actually, I want M90. Oh, wait. Let's check here. Yeah, M92. I always forget what these commands are. G91 does put it in relative mode. G1, E100, F50. I'm actually going to change that up a little bit. So G1 is move it speed 1, but we're going to override the speed anyway. E100 is telling the extruder, so not one of the X, Y, or Z steppers, but the extruder, to spit out what it thinks is 100 millimeters of filament. F is the feed rate, saying how fast to spit that out. I'm going to do feed rate of 100 millimeters per minute, so it only takes 1 minute for it to come out. So G1, E100, F100, and you can start to see it's spitting out some filament. Now I'm going really slow because you could certainly F2000 or whatever, and it would just run it out really quick. But if you go too fast, first of all, this motor never actually operates very quickly anyway, because you can't spit that much filament out of your hot end, the nozzle. But I also don't want to run the risk of skipping anything. I don't want to make it go too fast and it skips steps. That's what happens when maybe you have a loose belt or something's binding, or you try to go too fast. The stepper motor can skip some of those steps. It doesn't count them all. And so I'm going relatively slow. So it's getting close. I've told it to output 100 millimeters, and it finished. I'm going to cut it off again flush. All right, now let's look at our little deal here. So I should have 100 millimeters of filament here, and I'm pretty much right on it. Like that to there is 100 millimeters. It would be better, you know, to mark this thing out and then measure with a set of calipers. I do have a set of calipers, metric calipers, that I keep by the printer. Pretty much all the parameters that you're going to use on the printers are in millimeters. You can go in and change everything to inches, but I've never done that, and I don't think you'd ever really want to. But I would, just because not because inches are bad, but because of the amount of work it would be to change everything over. Everything else is set up in metric, and so I do have a set of metric calipers just for stuff like this. Again, you don't have to have that kind of thing, but for this particular one, you do need some way. It would probably be okay. I don't see my little scale. I normally have also a little ruler, but it is currently MIA. it would probably be okay to use just a ruler to get this measured versus calipers. But let's say that you were off. You were not at 100. Mine is right on 100. It's pretty much exactly 100 millimeters. But let's say you're off. What you do then is, now to use his calculator here, you have to look at what they actually did. So what he did is he marked 120 millimeters kind of on this side. So he marked 120 right here, ran out 100, and and that mark goes hopefully 20 millimeters to the beginning of the feeder. If you have a direct drive printer like he's doing on the website here, or even on this one, you can do it here on this kind, then that's a little bit easier way. But I like chopping it off here and actually, spitting out 100 and just measuring that. But what that does is this calculator doesn't work quite the same way at that point. So you do have to see your previous number. So that is from, going in here and finding the E value. So in our case, it's 98.14. And then what is the measurement between the marks, basically. So it's supposed to be 20 the way he set it up. And if you were over, like you over extruded, which usually doesn't happen, usually you under extrude. So if you over extrude, then this would actually be a negative number. Or well, it would be smaller than 20. It would, surely you wouldn't over extrude by 20 millimeters. If you under extruded, it'd be 20 plus the amount you need to add on to it. So you might have to, read through here, or just calculate it yourself. What percent are you over? If you know your current E steps and you know how much percent less or greater than 100 you actually extruded, then you can change that E steps number and run the same thing again. To change it, you go in let's see, we're on the screen. Yep. M92 E, and then whatever number you want to change to. So I'm going to use the same number I just had, 98.14. And then you could do M503 to check that it stored it in there, 98.14. And then you could do M500 to actually save it. So don't forget to do the M500. Or if you're using the control panel, don't forget to store settings. There's a store settings option in here. Control store settings is in here. So M500 and store settings are the same command. All right, so I think we have just enough time to at least start the last one. And then these set, the E steps, getting the bed level, and this next one, the PID tuning, it's kind of extra, not as important, but you might as well do it up front because it's a simple one to do. The last one, again, this is the ones that will most affect your print as far as getting it set up to where you're most likely to have a accurately sized print. Don't ever expect you're going to get these things perfectly accurate. If you ask it to print a certain size and it prints a little bit different size, that's kind of normal. But we want to control that as much as possible. Don't forget to reload your filament also. If you've taken this apart. Oh, I'm going to have to cut the angle on it because it's getting hung on the fitting there. There we go. Just screw that back in. Go ahead and hand feed the filament back. My nozzle's still heated up, so I can purge a little bit of it out. All right. This last one is the flow rate calculation. So I'm actually going to have to unplug USB because we need to go to Cura. And if Cura is running, then I can't use the prompter face. So I'm going to go ahead and close down prompter face. I don't need it. I guess I could have just closed prompter face and that would have been fine. Let me go ahead and start Cura opening. Cura sometimes takes quite a while to open. We're on 4.9.1 Cura right now. And that's a relatively, maybe in the past 2 weeks was that when that one was released. So what you're doing here with the flow calibration is we did E-steps, which sends out the right amount of filament. All of the G-code and all the slicing, it's all based on like a volumetric flow rate of filament coming out of the nozzle, and how much am I putting into the hot end, how much comes out. So it's all calculated assuming that I put in a certain amount of filament and I get out a certain amount of filament. That's also affected by just the diameter. So the diameter of this filament, your slicers by default assume this filament is 1.75 millimeters. So it wouldn't hurt measure the diameter of your filament and see if it's actually 1.75 millimeters, because all of your calculations that have to do with how much filament is coming out, or how much molten filament is coming out, would be affected if your filament is actually a bigger diameter or smaller diameter than what it thinks it is. So this flow rate calculator, how it works is we need to download this cube model. So I'm going to download that. I think Cura has opened, so let's get it on the screen. There's Cura. If you haven't already put in a printer, you know, if you haven't even gotten a printer going here, you might have to do that first. So add printer. It's probably not networked, so it's probably a non-networked printer. And then you pick your type of printer. By default, all of these Ultimakers are up here. Cura is produced by Ultimaker, the company, so that's why they're first. If you have the Ender 3, it's a Creality. So you go in the Crealities, and then you have all of the options here. There's the Ender 3 Pro. We just have the plain Ender 3. And you would add that printer. And then just take all the defaults to begin with. So I've already done that. I called it Summer 2021 so I could keep it track from these others. Alright, so let's load that model. So the little load button, it was called Cube STL. So the STL file, notice these are different. The first layer is .gcode. That's the actual commands that you can just send those to the printer. STL is a generic 3D file format. So we're going to load that. And we'll open it. And we're not actually going to print a cube though. We're going to set this up to print a hollow set of walls. So we can leave the 0.2 millimeter layer height. That's pretty normal. The wall line count, we want 1 line. Normally this is like 3 lines. You want 3 perimeters or 4 perimeters if you want it to be really strong, but we just want 1. Top and bottom thickness, we don't want any top layers, so 0 top layers. Normally you would want about 4 top layers. Bottom layers we'll do 2. Infill density, this is how solid the inside is going to be. So normally the inside of a printed part is not 100% solid. It's usually mostly air. But we're going to make it all air, so 0% infill. There's our 200 printing temperature and our 50 degree build temperature. Those are the numbers we tuned to, so we're going to use those. These print speeds, we'll go back over all these settings in more detail next time. This is just to get this print done. And if you're missing any of these, they're all listed out right here. I'm just showing you them in Cura. Leave the print speed alone. 50 is kind of your fast-ish safe speed, I guess. We don't need support. I could click that off actually. Build plate adhesion. We're going to do a brim. So this will build a set of lines connected to our print just to kind of help hold it down better. Normally I do skirt, but we're going to do brim. And then this special mode. This special mode probably doesn't show up on Cura. So in this search settings box, type spiral. And then spiralize outer contour, you check that. And then that will set this up in a special way so that when you slice it, your preview is, there's that brim, the cyan color is the brim holding it down. The yellow here is our bottom layer, or the top bottom layer. There's two bottom layers. And then I've got one perimeter. This, when we do the spiralize outer contours, this isn't actually layer on top of layer. It is, but they're spiraled. So it never actually finishes a layer. It just kind of gradually spirals up. And so you print this. And it takes, you know, it says it's going to take about 30 minutes to print, so we don't have time to do that. In fact, we're 1 minute over already. So let me show you what you do with it once you've printed it, because I already have it printed. So you get something like this. So there's the brim, and there's the little box it printed, and there's, you know, a bottom layer and a second bottom layer on top of that. And what you do is you go around. This is probably one place where only calipers will work on this. So I don't know that you'll be able to get any usable data. If you don't have a set of calipers, then this probably won't help you. So because you're going to be measuring it with a ruler and not going to be able to get what you need. And you want to measure the wall thickness at different types. You know, I did 8 different measurements, 2 on each side. And then average that wall thickness. The nozzle diameter from the printer is 0.4 millimeters. In fact, if we go back over here, wall line width, 0.4 millimeters. That's what we're aiming for. So when I printed mine, I actually got 0.46 millimeters as the wall thickness. So what that was saying is that even though we calibrated the E-steps and even though we did all this, it's spitting out a little bit more filament than what I anticipated spitting out. So to change that or to modify that, now the print doesn't look bad, but it does have a little bit extra filament coming out than what I expect it to have. So in Cura, well, actually over here in the web page, your previous flow rate, unless you've changed it, the default is 100%, just 100%. You were trying to print 0.4 millimeter walls. You actually printed 0.46 millimeter walls, and you can calculate your new flow rate should be, and then it's just the percentage, right? So 87%. That's really kind of low. I don't think it would actually go down to 87%, but I would probably try at 90%. To actually do that, that's in the slicer. So in your slicer, you can type in flow, and there is your material flow rate. You can change this number 100 to 90. And you can actually individually change other these, like the initial flow for the first layer. Maybe you do want a bunch of filament coming out to really get it stuck down, so you keep that at 100. This one probably does need a little bit of iteration. You know, change it to 90, see what the new print looks like, try printing some things, because it doesn't work quite as consistently. Like, you can't literally do a theoretical calculation on it and get it tuned in perfectly. It's a lot more of doing it by eye. So a lot of times this number, this flow rate number, 95% seems to be a good number. I'll try 90 and just see. We won't have time to do it today, but I'll do 90%, see if it looks any better. This is where you would go back and reprint. Now that you've done flow, E-steps, and got your bed level, you would go redo your baseline print and see how it looks. And then, you know, maybe tweak that flow rate again and see if that's going to need to go up. It probably doesn't need to go all the way down to 87%. That's pretty low. But those calibrations should get you set up. Notice there are a lot of others. There's stepper motor driver current, retraction, temperature, acceleration, linear advance. It even has X, Y, and Z on here. So there's a lot of others that we could do. We'll look at these later, particularly retraction and temperature. And I'll show you the stepper motor driver current. I'm probably not going to advise you doing that. Acceleration may not even be possible on your firmware. And well, acceleration is, but linear advance may not be. And then there's probably not any reason to actually do X, Y, and Z, but we'll look at it. All right, that should get you to where you can start printing reasonably good prints of anything. You know, you should be able to print. I would start with smaller prints, not 5-hour prints to start with, but you know, do this cube, do a benchy. I'll talk about the benchies next time. I actually brought one this time. Oh, I was going to bring my printer. I forgot to do that. Oh well, maybe next time. Here's what we're aiming for on these little benchies. Actually, this is not a perfect one, but you know, something like that. Go ahead and get some of those out there so I can give you some pointers on what to try next on your prints. I think these calibrations will be a good set of starting points. Oh, thanks for the great lecture. Thank you. I know I talk a lot of extra things, and some people just show me the detail, you know, what exactly I need to do, but I'd rather give you a whole bunch of extra stuff that there might be something useful in the extra stuff too. All right, I will see you guys on Wednesday. What are we doing Wednesday? Well, I actually have firmware listed in Wednesday. We'll do the temperature and retraction calibrations also, and we'll look at the firmware a little bit, maybe some more G-code. I don't think this bootloader topic, I don't think that's relevant anymore. If you know you need a bootloader, then let me know. But I think all the printers, if you don't even know anything about it, you probably don't need it. I think all the printers these days actually don't need bootloaders, which is good. All right, I will see you guys on Wednesday.